All right, it is your time for your Thursday notes. The warm-up very quickly is a review about parallel lines. Okay, we know parallel lines are the same slope, so our new equation should have the slope of 3 over 2. We have an x value of -8 and a y value of 12, and so you would use the point slope form. But that is just a review. We should already know that. Let's take a look at the new stuff we're learning today. We talked about exponential functions yesterday. Remember, they look like this. Okay, it's a curve. We talked yesterday about some different things, about writing equations for these lines, right? We would need the y-intercept, or the initial value, which in this case is 3. And then we would need what it's changing by. So this is 6. So it goes from 3 to 6 by or actually from 6 to 3 by multiplying by 1/2. So that means that is my b. So my equation would be y equals 3 parentheses 1/2 to the x power. That's what we talked about yesterday. Hopefully you feel pretty good about that. Okay, but that's not exactly what we're talking about today. Today we are going to look at the domain and the range of exponential functions, as well as some key features of functions. We hit on some of those yesterday. Remember, some review: domain is all x values, range is all y values. If there is an endpoint that's a closed dot, right, that would be an or equal to sign. And if it's an open dot, it would just be greater than or less than. And the other option would be if it has an arrow, it means it goes on forever. So let's talk about some domain and range. Let's start with the domain. Remember, the domain is the x values. It's how far does this graph go to the left, and how far does this graph go to the right. That is the domain, right? That's what we're talking about. How far does this graph go left and right? So how far does it go left? And this is kind of a tricky question because it looks like it's about to start going straight up, right? But it actually never does go straight up. It actually continues, even though it gets really high, it continues to keep going left. So that means it's going to go forever to the left. And more obvious would be it goes forever to the right. So if it goes forever to the left and forever to the right, hopefully you remember that means the domain is all real numbers, right? Or we use this symbol, okay? Because it goes forever left and forever right. Let's talk about the range. Okay, the range is how far does it go up? How far does it go down? So how far does it go up? It goes up forever. Obviously, right? That's the easy one. How far does it go down? We talked about this yesterday. It goes down, and as it goes down, it starts to flatten off. And yesterday we learned a vocabulary word that is actually kind of the border of how low it can get. It won't ever cross this line. Do you remember what that name of that line is called? Probably not. Maybe the smart people remember, or people that are paying attention, I should say. That is an asymptote. So just a preview of what's coming up on the back. Okay, we talked about that word yesterday. Okay, that's that invisible line. Well, that invisible line affects the range. So it will always affect the range of a exponential function. So our range, since it has one arrow and then it has one stopping point, we're going to use y. And we got to figure out what the stopping point is, which is 0, right? It doesn't go, it stops at the y value of 0, does not get down to -1 or -2 or anything like that. So y and 0. And then how do these other points on the graph, how do those other y values compare to 0, right? hopefully you said that they are bigger than 0. And should we put a line underneath this? The answer is no, you should not, because remember, the line that comes down here will never ever touch the asymptote. We talked about yesterday. It definitely looks like it touches right here. It definitely look like this line touches the x-axis. Definitely looks like it. But if we were able to zoom in, and again, obviously not going to work here, but on a calculator, then you would be able to see that as you zoom in, it does not touch. There's still space there. So the range is just y is greater than 0. So for exponential functions, if there are 2 arrows, the domain is always all real numbers. The range will always be like this, but the number will change depending on where the asymptote is. So this number right here is very dependent on where the asymptote is. All right, so if you looked at this one, it's flipped upside down, but it's got 2 arrows, right? So since it has 2 arrows, the domain is all real numbers. It goes forever left and forever right. And then the range, again, the asymptote still at 0. So we know it's going to be y and it's going to be 0. Right, that's where we get the 0 from. It's because that's the y value of 0. And then how does our graph, how do the points on this line, how do the y values on this line compare to 0? Well, -1, -2, -3, those are all less than 0. Again, we will leave the or equal to sign off because it will never be exactly 0, right? It will always be less than or greater than. Okay, so moving down, okay, we've got some points here. Okay, so we would put them on the graph, and really we know the domain's going to be all real numbers because when we put them on the graph and connect the dots, they will be connected with arrows. What we really got to figure out is where the asymptote is. So that's really the only reason why we would want to put these on the graph, is so that we could figure out where's the asymptote. And this should look really familiar because this was on our notes yesterday. As you see, these are the points that are on here. And if you kind of continued the pattern, so hopefully you can see the pattern is times 2 times 2. So if we went backwards, it'd be times 1/2. So if I went backwards again, we'd get 0.25. And if I went backwards again, we'd get 0.125, right? So it's going to end up giving me a lot of really small decimals that are very close to 0, but it will never get to 0. So that means my asymptote is at 0, which means my range is y and a 0. And these y values in this table, hopefully you see that those numbers are all bigger than 0. So there's the domain and range. For a graph, or for an equation, again, we're going to assume that when you graph this equation, it has arrows on it, right? So that means the domain is all real numbers. I know someone said it. Probably Gary. Gary probably said it. Okay. And then the range, a little trickier here. Okay, so I'm going to give you a little pro tip, okay, that we really don't see a whole lot. Typically, when we look at our equations in Algebra 1, our asymptote will always be at y equals 0. And the way we know for sure that my asymptote is y equals 0 here is that the asymptote only changes when there's a number added or subtracted. So whatever number is added or subtracted at the end, that would be the asymptote. So what number is added and subtracted? the answer here is, for this question, is 0. That means my asymptote is y equals 0. And we know this is going to be exponential decay. So it's going to look like just like this. So that means the range is y, 0, and it's going to be greater than 0. Because again, all these y values on this graph are bigger than 0. And then finally, we got these two endpoints and one endpoint and one arrow. This actually is just the exact same as what we did when we first introduced this concept in September or August. Okay, so it really doesn't matter what this line looks like in between, right? If it was straight like this, the domain and range isn't going to change at all, right? Because it's got two endpoints. So let's talk about how to figure that out real quick. Again, domain's left to right. So how far left does it go? Well, it goes to 0 left, right? So it starts at 0. How far right does it go? Well, it goes to 3. We put an X in the middle. We put some less than signs in. And then we just figure out that this one gets a or equal to because that is closed. And this one stays without an or equal to sign because it's an open dot. Okay, the range, we do the exact same thing, but now we work from bottom to top. So it goes down all the way to 1. We put a y in the middle. It goes up all the way to 8, two less than signs. And again, since this one is open at 1, oops, don't do that. Okay, no line. Since this one is closed here, that does get the line. Okay, so again, the domain and range of this line does not change if it's connected by a straight line, because it still covers all the same x and y values. One endpoint inequality, right? Nothing really changes here. The domain is not all real numbers. Okay, it goes forever to the right, but it stops right here. So what x value does it stop at? If you said 1, you're wrong. That's the y value. The x value is down here. It's 0, right? That point is 0, 1. So x, 0. And these x values here on this curve are all bigger than 0. So x is greater than 0. And it stays just greater than because open circle. Range, very, very similar. Okay, we know it goes forever up, but it does not go forever down. So where does it stop going down? Well, that would be at 1. So y and 1. And if I look at all these points here, now we focus on the y values of these points. 8, 7, 6, 5, those are all bigger than 1. And again, no line underneath. So that's domain and range. We've done the new stuff would be this up here. This is new. These two are old, right? We've done these before. So if you didn't know how to do these, shame on you. Okay, you weren't paying attention earlier this year. Okay, that'll be on the test we get when we come back from Thanksgiving. Now let's talk about some key parts of these graphs. We talked about a lot of this stuff yesterday. Exponential functions are written in this form. What does A stand for? Y-intercept, or initial value. And what does B stand for? B is the common ratio, or you could say growth or decay rate, right? Either one of those is fine. It's how the graph is changing. If B is greater than 1, then the graph will be exponential growth and show I don't even know what's supposed to go there. Show increasing. Maybe it's supposed to be increasing first, then growth. I don't know. Let's just ignore these. If B is less than 1, it should be decay. And you know how I know these notes aren't very good is because technically speaking, mathematically speaking, that shouldn't be b is less than 1. It should be 0 is less than b is less than 1, because it needs to be a fraction or a decimal. Less than 1 can't be negatives. So we don't want any negatives as b, right? So that's the note's fault for having these two things I didn't know. All right, asymptote we talked about yesterday. Asymptote is an invisible line that the graph approaches but never crosses. The asymptote of an exponential function is always horizontal. We talked about that. And will always be in the y equals a number form, right? That is hoi. You will be writing equations of asymptotes, right? One to go y equals number. Okay, mostly it'll be y equals 0. But sometimes it'll change, and we'll see some examples. And then range, we just talked about domain and range, right? The range is affected by the asymptote. Okay, this number will always be the same as the number in the range. So if you want to find the range of an exponential function, find the asymptote. Since the graph never touches, the range will be written with, I guess, greater or less than signs. Because it's not included in the function. All right, and now let's actually get to the fun part. Y equals 4 times 2 to the x, right? So we can graph this. We know it starts at 4 because that's my y-intercept. And then for those of you who are smart, will know that b is the growth rate, right? It's growth. And how does it grow? Times 2. So 4 times 2 is 8. 8 times 2 is 16. And you can even go backwards. 4 divided by 2 is 2. And then 2 divided by 2 is 1. And then 1/2. And then 1/4. And then 1/8. And that's the line. The asymptote then would be right here. That is a horizontal line, so that's going to be y equals. And what y value does this go through? That's right. If you said 0, you are correct. Good job. It has arrows. It means the domain's all real numbers. We talked about that on the front. The range, again, we use the same number here, right? That's the same number 0. And what happened to all these y values? All these y values are bigger than 0. And the end, we finished. Okay, these are very important things you need to know. Okay, these are basically test questions that we will see on the Chapter 7 test. You will be asked about the asymptote, the domain and the range, the y-intercept, and whether it's growth or decay based on this. So from an equation, you need to be able to know all of those things. Let's do number 2. Graph the equation shown and identify its key features. What's the y-intercept? 3. What's the growth or decay rate? 1/2. Well, since it's 1/2, what does that mean? Decay. What is the y-intercept? We already said it was 3. Let's graph. So as I move from left to right, 3 times 1/2 is 1.5, which should be somewhere in there. 1.5 times 1/2 is 0.75. All right, those aren't very familiar numbers. So let's go the other way. Instead of multiplying by 1/2, let's multiply by 2 and go backwards. So 3 multiplied by 2 should be 6. 6 times 2 is 12. 12 times 2 is 24. Now it looks more like an exponential decay. And there we go. So there's my graph. Again, we see that our asymptote is right here on the x-axis, which is going to be y equals 0. Again, remember the hint we talked about earlier. You can always tell the asymptote from the equation based on what is added or subtracted at the end. So if there's nothing added or subtracted at the end, then our asymptote is nothing, aka 0. So the domain, again, it has arrows. So just like on the front, the domain's always all real numbers. And the range, again, is connected with this asymptote. So it's y and it's 0. And all these y values are numbers bigger than 0. So boom, here we go. So again, very important that you can look at an equation and determine all 5 of these things, okay, as well as graph, right? That's super important. Hopefully, after today, you feel good about doing that. And if not, watch this video again until it makes sense. Listen to it while you sleep so it just absorbs into your mind. Okay, these are slightly different. Okay, again, we talked about equations. You can always tell where the asymptote is. Again, the ones that we see all year, the asymptote will be y equals 0, right? Pretty much every time. Unless they give you something crazy like this. In this case, the asymptote is going to change a little. And you can see the asymptote is now going to be here, which we're going to assume 1, 2 is at 2. It is horizontal, so it's still y equals 2. It's got arrows, so domains are real numbers. The range is y is greater than 2 because this number is 4 and 4 is bigger than 2. The y-intercept is sitting at 3, which is also bigger than 2. And this is growth because as we go from left to right, it is growing. It's getting bigger. We call that growth. Okay. We typically do not see exponential functions turned upside down like in number 4. Okay, we don't know what equation that would be, right? So we typically won't ever see these from an equation, only in weird problems like this. Nothing really changes. Here's the asymptote. What number is that at? Well, that's at 1. So the asymptote is y equals 1. All right, the domain is all real numbers because it has arrows. And this time, if I look at the other values here, this is 0 and -1 and -3. Those numbers are all less than 1. So that's my range. The y-intercept is 0. And this is, I don't even know if that would be growth or decay. All right, so let's look. So it's kind of tricky and really kind of impossible. Well, it would be -1, right? So if you took, it'd be 1 and then 2 and then 4. So the growth, it's actually growth, which is very confusing. And you can look at these and like not find a pattern because 0 times what is -1. So that's very confusing. But it's been translated up 1. So the equation would be something, again, it's so weird. Man, it would be, I really don't even know how you would write this equation because I don't know how to write an equation that does this, that makes it flip upside down. So just trust me, it's growth, and then trust that you won't ever see something like this. So, okay, kind of ignore that. Okay. Last one, now we're pros. Y equals -1, because that's where that is. Domain's all real numbers. Range is y is greater than -1. The y-intercept looks like it is at 2, and this is, nope, not growth, it's decay. Okay, so there is domain and range of exponential functions, as well as some key features. What you need to do now is this lesson practice right here. And if you finish that, you can move on to this homework. Okay, remember this homework is due, is a grade, right? So you need to get it done. And then this is just, it's not a grade, it's extra. All right, be good for the sub.